Welcome to Cool Fire News, the podcast where we break down the latest in technology and innovation. I'm Siri, and today, we're diving into the fundamentals of networking. Whether you're a tech enthusiast or just curious about how the internet works, this episode is for you. Networks are all around us, powering our smartphones, computers, and even smart home devices. But what exactly is a network, and how does it function? Today, we'll explore the basics of network technology, its components, reference models, standard protocols, IP addressing, subnetting, routing fundamentals, and its importance in the digital world. Segment 1. What is a network? A network is simply a system of interconnected devices that communicate and share resources. These can be as small as a home Wi-Fi setup or as vast as the internet itself. There are several types of networks, including LAN, local area network, used in homes, schools, and offices. WAN, wide area network, spans large areas, like cities or countries. WLAN, wireless local area network, a wireless version of LAN, using Wi-Fi. MAN, metropolitan area network, covers a city or a large campus. PAN, personal area network, connects personal devices like smartphones and smartwatches. Understanding these network types helps us see how data moves and connects people worldwide. Segment 2. Key components of a network. Now that we know what networks are, let's talk about the key components that make them function. Router, directs data between different networks. Switch, connects multiple devices within the same network. Modem, converts digital data to analog signals and vice versa. Server, stores and distributes data to client devices. Firewall, protects the network from unauthorized access. Each of these plays a crucial role in ensuring seamless connectivity and security. Segment 3. Network reference models. To understand how networks communicate efficiently, we rely on network reference models. These models standardize networking processes and ensure different devices and technologies can communicate effectively. The two primary models are OSI model, Open Systems Interconnection. This model has 7 layers that guide how data moves through a network. Physical layer, deals with hardware transmission, cables, signals. Data link layer, manages data framing and error detection. Network layer, handles routing and IP addressing. Transport layer, ensures reliable data transfer. TCP, UDP. Session layer, manages connections between devices. Presentation layer, converts data into a readable format. Application layer, provides services like web browsing and email. TCP/IP model, a simplified model with 4 layers commonly used in the Internet. Network interface layer, similar to OSI's physical and data link layers. Internet layer, corresponds to OSI's network layer. Transport layer, similar to OSI's transport layer. TCP, UDP. Application layer, merges OSI's top 3 layers. These models help engineers design and troubleshoot networks efficiently. Segment 4. Network standard protocols. Network protocols define rules for data exchange and ensure seamless communication between devices. Some key standard protocols include HTTP/HTTPS, Hypertext Transfer Protocol Secure, governs web communication, with HTTPS adding encryption for security. TCP/IP, Transmission Control Protocol Internet Protocol, the fundamental protocol suite of the Internet. DNS, Domain Name System, translates domain names into IP addresses. FTP, File Transfer Protocol, facilitates file transfers between systems. SMTP IMAP POP3, email communication protocols for sending and receiving messages. SNMP, Simple Network Management Protocol, used for network monitoring and management. DHCP, Dynamic Host Configuration Protocol, automatically assigns IP addresses to devices within a network. These protocols work together to enable communication, security, and efficiency in network environments. Segment 5. IP addressing and subnetting. IP addressing is a fundamental concept in networking, allowing devices to identify and communicate with each other. There are 2 types of IP addresses. IPv4, Internet Protocol version 4 uses a 32-bit address format represented as 4 octets, e.g., 19.216.811. IPv6 Internet Protocol version 6 uses a 128-bit address format to support a larger number of devices, e.g. 2000, 1DB8FF042 8000, 329. To manage network efficiency, we use subnetting, which divides a large network into smaller, more manageable subnetworks. Subnetting helps with reducing network congestion by limiting broadcast domains, enhancing security by isolating different departments or users, efficient IP address allocation to prevent wastage, subnet masks, e.g., 255, 255, 255, 0 define the network and host portions of an IP address, ensuring proper routing of data. Segment 6. Routing fundamentals. Static and dynamic routing. Routing is essential for directing data packets between networks. There are two main types of routing. Static routing, manually configured by network administrators, suitable for small networks with predictable traffic, less overhead but lacks flexibility in case of network failures. Dynamic routing uses protocols like RIP, OSPF, and BGP to automatically adjust routes. Ideal for large and complex networks. Adapts to changes in the network for better efficiency. Choosing the right routing method depends on network size, complexity, and administration preferences. Segment 7. The future of networking. Networking is constantly evolving. Here are some exciting developments on the horizon. 5G and beyond. Faster, more reliable wireless connectivity. AI in networking. Automated monitoring and security enhancements. Edge computing. Processing data closer to its source to reduce latency. Quantum networking. The next level of ultra-secure communication. These advancements will shape the future of digital interactions and connectivity. Closing remarks. That's it for today's episode of Coolfire News. We explored the fundamentals of networking, its components, reference models, standard protocols, IP addressing, subnetting, routing fundamentals, and the future of connectivity. If you enjoyed this episode, don't forget to subscribe and leave a review. Thanks for listening, and until next time, stay connected.